Hi guys, so we are going to continue vector addition with just one proof tonight. I know you had a lot to learn yesterday, so today is just an extension. Okay, so this is a rather complicated proof, and I just want to put it out there that I don't want you to worry about, oh my goodness, I could have never come up with this myself. I want you to just kind of try to learn as I explain it to you, some new techniques so that perhaps in the future, when you do have to do more proofs, if you go on with this in university, that you will have some familiarity with proofs, okay? So this is question 17 from page 292. So the first thing I want to do is just copy it down and make sure that you understand it. So PQR is a triangle and it has three medians. So remember, medians bisect the side and go through the opposite vertex. So they meet at a common point. In this case, we're calling it G. Now, in this particular case, the point G divides each median in a 2-to-1 ratio. So this is a known fact. This is not something we found. This is something that the question is giving us, and we will use it as a fact later. So they want us to prove that GP plus GQ plus GR equals the zero vector. So in other words, if you took GP and GQ and GR and added them together, you would really get back to start, is kind of how I think about that. So I'm going to show you two different ways that you can use to solve this. Okay. We're going to be using some linear reasoning to do this. Okay, so the first thing I'm going to get to is that GQ plus Q, we're going to call this point M. That's going to be crucial to understanding this, okay? So we are labeling this point M. So the midpoint. So we know that GQ, so if you go from G to Q, and then from Q to M, and then from M to G, you are going to get the zero vector, okay? Because in essence, you go back to start, right? Now, the same thing is true for GR, vector GR, to vector RM, to vector GR, and then at vector M to G. So notice that this vector M to G is used twice, okay? So now we can, because these two sums individually sum to the zero vector, we can conclude then that GQ plus QM, okay, these all need vector things, plus MG, okay, so there's the first addition, and then GR plus RM plus MG all sum to the zero vector. Okay, but we can rewrite some of these in a different way. Okay, so I'm going to rewrite the order of some of these. Okay, below. Okay, because these are commutative. So I can rewrite this as GQ plus QM plus RM plus GR, and I'm going to write 2mg, because there are two of them, equal the zero vector. So all I've done is move some of these addition pieces around, and instead of writing an mg and an mg, I've written it as 2mg. So there are two different conclusions we can make. Well, look it up at QM and RM. Those are opposite vectors, so those actually sum to the zero vector. Another conclusion that we can make is that 2mg is actually equal to GP. Why is this true? This is because of the 2-to-1 ratio. So this is a 2, the 2-to-1 ratio. My diagram is poor, but this is a 2-to-1 ratio. So therefore 2 mg's will equal 1 GP. So therefore we can conclude that GQ plus GR plus GP is equal to the 0 vector, which concludes our proof. Okay. There is one more way of describing this. Okay, another way of proving this. All right, or we can do it that GQ, so refer to your diagram, plus QM is equal to the vector GM. You can refer to your diagram. Hopefully that makes sense to you. But GR plus RM is equal to the vector GM. Okay, so we can do a summation here and show that GQ plus GR, and now QM and RM sum to 0, so the 0 vector is equal to 2 GMs. Okay, so we can rearrange this then to be GQ plus GR plus 2mg. Okay, now why can I rearrange? Because I'm putting it to the other sign, and that 2mg is the same as 2 negative GMs. Okay, so that's just using negative or opposite vector notation. Okay, and then same reasoning as before, the 2-to-1 ratio, we can get that GQ plus GR plus GP is equal to the 0 vector. Okay, so again, it's a bit complicated if you would try to come up with that on your own, but hopefully you can see the technique here of how vector addition can prove something like this. So thanks for watching, guys. Hope you learned lots.